No, question 19. Oh, okay, we got a geometry question. In the given figure, in three semicircles, each of the three semicircles has a diameter that equals a corresponding side length of a right triangle, S and T. S and T are the area of two smaller semicircles. What is the area of the largest semicircle represented by S and T? Okay. So the question gave us a shape that had a right triangle in the middle, and all these round shapes were semicircles, so half of a actual circle.
Yes, sir.
Yeah, so this is 90 degrees. The area of this semicircle is given as S, and the area of the smallest semicircle is given as T. So these are both areas, right?
Yes, sir.
So how could we kind of approach this question? So what I suggest doing here is uh, so let's put these two lengths of the right triangle, the two bases, to the two legs as each as A and B.
Yes, sir.
So just any alphabet or symbol that you want to use.
Yes.
And because we know it's a right triangle, this length using Pythagorean theorem will be root A squared plus B squared.
Yes.
Correct? Yeah. So we managed to label the diameters of all three semicircles, right?
Yes, sir.
So because these are diameters, we can also find the radius, correct?
Sorry, sir. I didn't heard.
We can also find the radius of all the
Yes.
semicircles, yeah, by just halving these. So radius of this semicircle will be A over 2.
Yes.
Yeah, radius of this circle will be B over 2. And the radius of this semicircle will be root A squared plus B squared over 2.
Yes.
So these are our radiuses. So we can uh, write relationship. So let's say, what is the area of T using A and B, right?
Yes, sir.
Yeah, so the radius of was A over 2. So the original whole full circle would have been pi times r squared. But because it's a half circle, we have that area, right?
I read. Yes, sir.
Yeah. So this will equal, it will be 8 at the denominator, and then a squared times pi.
Yes.
Yeah. So we rewrote t using a and b. So the reason for doing that, you'll kind of understand soon. So we can also rewrite s using the same way we did with t, such that the whole circle is pi times b over 2 squared, and then half of that, which
Yes.
will equal 8 over b squared times pi, correct?
Yes, sir. Correct.
Yeah. So, and now we can see, let's say we needed to find the area of this semicircle, right?
Yes, sir.
Let's say this is a semicircle called, just any number, let's say K. Yeah. So what is the area of K? This can be, so area of K can be written as using this radius that we found. It'll be whole circle, a squared plus b squared over 2. Square that, and then half it, which will give us 8 under a squared plus b squared, and the whole thing is multiplied by pi.
Yes, sir.
And the question asked us to rewrite the area of k in terms of t and s. So how
Yes.
will we do that? So that's why we change the areas of t and s into these two, so that they
Yes.
use the same variable as the area of k.
Yes.
So this can be rewritten as, you can see that it's a squared p over 8, which is this part. Do you see?
Yes, sir.
Yeah, so this will be t, And we can also see that for s is b squared times pi over 8, which is this part.
Yes.
Yeah. So it'll be plus s. So the final answer, k, the area of k can be written as t plus s.
Yes.
Yeah. Do you understand everything here?
Yes, sir.
Yeah. So it's just, yeah, finding areas, finding the radius in terms of two variables. Find the areas using those, and then match t and s with this to find our final answer.
Yes.
Yeah. So no questions for this one?
No, no, sir.
Okay. Then we can move on to the next question. Right, number 20. A bicycle lock consists of a 3-digit password. Each digit of the password can have an integer value from 0 to 6, where the same number may appear more than once. A different order of the same combination sets a different password. For example, 656 and 566 are two different valid passwords. What is the number of different passwords that can be set in the lock? Okay, so we have a bicycle lock that has a 3-digit password, correct?
Yes, sir.
So we want to know how many number of possible passwords we can make. So each digit can have a value that's from 0 to 6.
Yes, sir.
So if you think of it, examples could be like 0, 0, 0, 1, 2, 3, and 3, 2, 1. And the question said that even if the same types of numbers, so 1, 2, 3 are used, if their orders are different, like for these two, then they are regarded as two different passwords, correct?
Yes, sir.
And so this can continue until our largest value, which is 666. So how would we find this? So what this can be is a type of possibility question. So 0 to 6, we
Yes, sir.
have a total of 7 types of numbers we can use, correct?
Yes, sir.
Because from 0 to 6, there's a total of 7 numbers. Because including 0 and 6. So there can be
Yes.
7 values for each of these 3 digits. So do you kind of understand that the total number will be this?
7 times. Yes, sir. 7 power.
Yeah, so it'll be 7 to the power of 3 because there's 7 possible values for each of these. So we multiply all these possibilities to get our total number, which is 7 to the power
I
of
think for this answer, I consider 6 power 3 as an answer, and I
6
forgot
power
that
of 3.
it has 7 digits.
Yeah, you could have thought that because it's until 6, right? Yeah, but
Yes,
if
sir.
it's 0, 1, 2, 3, 4, 5, 6, it's actually a total of 7 numbers.
Yes.
Yeah, so this is something you have to be kind of careful about. Yeah. If it was 1 to 6, then it would have been 6 to the power of 3, right?
Yes, sir.
But we have one extra number, which is 0. So that's why it'll be 7 to the power of 3.
Yes.
Yeah, okay, so everything's good?
Yes, sir.
Okay, last question, number 22. Okay. Oh, this one seems a bit complicated. Let's take a look. So Jason throws a dart at a dartboard where he can score 1, 3, or 5 points, depending on the area at which the dart lands. The dartboard is designed with concentric circles. So let me just ask you, do you understand concentric? No worries?
Uh, Concentric, it means circle within a circle, I think.
Yeah, so the origin, so the midpoint of the circle is always this is the same for all 3 circles.
Okay. Concentric.
So you can see the point K in this graph is the middle of the core center of the circle, right?
Yes, sir.
Yeah. So what the dartboard is designed with concentric circles means is that the centers of all 3 circles are the same at the same point K.
Yes.
Yeah. So where each circle has a radius twice that of the smaller circle. So the radius increases by 2 times for each circle. Given that the radius of the smaller circle is 3 units, find the probability that Jason scores either 1 point or 5 points. Okay. So we have the smaller circle for 5 points, a slightly bigger circle for 3 points, and the biggest circle for 1 point. Sorry for my kind of bad circles. Yeah. So let's say this is center K. We know that, let's just say this has a radius of just R.
Yes.
Then the radius of the middle circle was, in the question it says it was twice that of the smaller circle, so it will be 2R.
Yes.
And then for the even larger circle, here, it will be twice the circle that was one size beneath it, which was 2R. So this whole length will be 4R.
Right.
Yeah. So, and the question is asking for probability that Jason scores either 1 point or 5 points. So 1 point is this area, right? And 5 points is
Yes, sir.
this middle circle.
Middle.
So how we can find it is total area of the dartboard and it will be area for 1 point, which is the middle, right? And then we can have area of 5 points. So this will be, oh, sorry. This will be this part, and this will be this middle part. Do you kind of understand? Because it'll be total surface area over the area that we need. So for this,
Yes.
Let's start with the denominator at the bottom, total area of the board. So we know the board is just a circle with radius 4R. So we can use pi r squared. So pi r squared. That's the total area, and the area we need for, let's start with simple one, A5, which is this middle circle with just radius R, will be part R squared, pi r squared. Is there a problem, Nawarj? Or do you understand?
Sorry, sir?
Do you understand until now?
Yes, sir. I understand.
Okay. Yeah. So a kind of more difficult one is finding the area of the 1 point. So this outer part. We can do that by having the most outside circle minus the area of this inner circle to only leave the kind of ring, right?
Yes, sir.
Yeah. So that will be the circle for the outer circle, the area, minus the middle circle, which will be pi 2R squared. So this is this. Do you kind of understand, Norwich?
Yes, sir.
Okay. So then this can be rewritten as 16 pi r squared. And on top, it'll be pi r squared plus 16. So this will be 16 pi r squared minus 4 pi r squared, right?
Yes, sir.
And then we simplify that to be over 13 pi r squared. Yeah.
Yes,
So, and we know that pi r squared are both on top and bottom, so we can divide those, leaving only 13 over 16, which is the probability
yes,
that one will score 1 point or 5 points.